So, Tim and Josh have a combined mass of 120 kilos. If they're riding in a grocery cart at 20 meters per second that has a mass of 20 kilograms and run into a parked smart car weighing 200 kilograms, how fast will the smart car go east if after the collision Tim and Josh go east at 8 meters per second? So first thing I'm going to do is draw my little chart. I'm going to have initial, and then I'm going to have final. In orange, I'm going to have Tim and Josh. So Tim and Josh have a combined mass of 120 kilos if they're riding in a grocery cart. So they're in this cart. Well, the cart has mass too, right? So the grocery cart at 20 meters per second that has a mass of 20 kilos. So notice Tim and Josh are actually inside this grocery cart. So here's Tim. He's wearing a hat. And here's Josh. And he's not wearing a hat. So their combined mass, the cart and Tim and Josh, would be 140 kilos. I get that from adding the cart plus Tim and Josh because they're moving as one unit. It also says that their velocity is 20 meters per second. They run into a smart car that weighs 200 kilograms. Okay? It is parked, so its velocity would be 0 at the beginning. So we're going to have this car, its velocity is going to be 0 meters per second for initial, and its mass is 200 kilograms. So right here we have the left side of what's going to be our equation. Because we have this object, this object. Notice we have a mass here, velocity here, mass here, velocity here. We're going to add these, and it is going to equal our final. So let's see how many pictures we have on our final to see what it equals. How fast will the smart car go east if after the collision Tim and Josh go east at 8 meters per second? Okay? So notice it gives us a velocity of Tim and Josh, but it wants us to find the velocity of the car. So that means they're not going together. Nowhere does it say they get entangled or that you should add their masses. It doesn't say that they are moving as one unit, and so we have to draw two different pictures. So first it says the car, so we're going to draw the car. Does its mass change? Shouldn't, so it's 200 kilograms. The velocity, the VF, we don't know it, so it's a question mark. We're going to add that to Tim and Josh, which their mass does not change. So we have Tim and Josh, again in their grocery cart. Tim's hat fell off. Their mass does not change. Their velocity, however, did. Notice it is now 8 meters per second. So now we have mass and velocity plus mass and velocity equals mass and velocity, this is our unknown, plus mass and velocity. We know everything but this VF. So when we write it for our givens and our unknowns, start it over here. So our givens, we have 140 kilos. This will be the mass. I'm going to just put T for Tim and Josh. And then we also have the velocity initial of Tim and Josh, which was 20 meters per second. And then we have the mass of the car, and it was 200 kilos. And then we also have the velocity initial of the car, which was parked, so 0 meters per second. Then we have the mass of the car. We already have that written down. It doesn't change. We already have the mass of Tim right there, mass of the car there. We do not have the final velocity written down, so you can either write it up here or here. It does not matter. It's just under the givens. So velocity final, and we know it's a velocity. It's under final, so we know it's final velocity, and it's under the picture of Tim and Josh, so we know it's velocity final of Tim and Josh. and it is 8 meters per second. The only thing that does not have 2, a mass and velocity, is the car. So for our unknown, it is going to be the velocity final of the car. So our equation, based off the picture, we're going to have this mass, this velocity, plus this mass, this velocity, equals this mass, this velocity, plus this mass, this velocity. That is our equation. We get it from the picture. So the equation, that's why I'm going to color code it. Mass of Tim, velocity initial of Tim, because it's under initial, plus mass of the car, velocity initial of the car, is going to equal, notice the line splits, equal sign, mass of the car, velocity final of the car, plus the mass of Tim and VF of Tim. We are solving for the final velocity of the car, so we're going to subtract this side first, the MT VFT, and then we're going to divide by MC, because we're going to do PEMDAS backwards. So first subtract, then divide. So we're going to have MT VIT plus MC VIC equals MC VFC. Sorry, we're going to subtract. Subtracting this, MT, VFT. So we're going to subtract here. So what you do to one side, you have to do to the other. And it is going to equal MC, VFC. For VF, to get it by itself, we're going to divide by mass of the car. So we have to divide this whole thing by the mass of the car. Notice it cancels these two out, so we're just left with final velocity of the car. So now here we're just going to plug it in. So we know the mass of Tim, 140 kilos. Velocity initial of Tim, 20 meters per second. Plus mass of the car, 200 kilos. Velocity of the car initially was 0 meters per second. Then we're going to subtract the mass of Tim, 140 kilos, and the velocity final of Tim, which was 8 meters per second. We're going to divide all of that by the mass of the car, which is 200 kilos. You should get an answer of 8.4 meters per second.